Hello everyone and welcome to another video. I thought I would do a video about all the key impact concepts that I've learned throughout the years that I think are most useful to know, and maybe I wish I would have known actually sooner. These are kind of coming from my own experience, from things I've learned online, from things I've seen that work or don't work, or just by being curious and watching a lot of other content by people on YouTube or reading books and things like that. I hope that they at least spark your curiosity, that you learned something as well. If you didn't know these already, I hope that you actually try some of these or think about these things in some sense. And I will start kind of slowly with more general things, and then I go into more specific things. But I'm trying to keep it a bit short since my last videos were a bit long, so let's get to it. So the first one that I think is really impactful is to think about artificial fertilizer and how that has impacted us both in a positive and a negative way. So in a sense, the positive way is that we exist. There's so many people right now because we figured out a way to create artificial fertilizer, specifically through the Haber-Bosch process, which extracts nitrogen from the air using energy, as well as mining. All of this has enabled us to grow a lot more food than would otherwise be possible. Of course, as a consequence of that, maybe as a negative impact, you can see here we have open mines and pollution from that, as well as eutrophication here in the image with the algae bloom. So thinking about that, thinking about how if you're doing growing, what type of fertilizer you're using, if you're using artificial one, that has an impact. And maybe you can start thinking about maybe there's only certain scenarios where I would like to use that or I should use that. I think that's already something important to know when you're doing any type of growing. The second one is maybe a bit more of a conventional topic, and usually when I tell people that I do hydroponics and I explain what it is, you grow plants in the water with a nutrient solution, the first thing they ask me is, isn't that too much water? Aren't you overwatering them? And that's because most people that don't know hydroponics just associate a lot of water with bad growth or killing a plant. That's because a lot of history, and there's a lot of even hydroponics itself is relatively new, and all we understanding all of these different concepts took a while to get to the point where we actually understand what's causing this. So usually when people think about overwatering and the plant dying, they're thinking about root rot, which is actually microbial in nature. So of course, just growing a plant with its roots constantly submerged in a nutrient-rich solution is not going to kill the plant, otherwise we wouldn't have hydroponics. However, under certain conditions, you can have that. So what's actually causing that usually is either a combination of a certain fungi called Pythium. It's not necessarily just one, but there's different types, of course, or algae. These things in low oxygen conditions or high oxygen conditions can actually attach themselves to the roots and cause this rotting that prevents the plants from growing. So if you already know about hydroponics, I know you know this concept, but it's still important to go a step deeper. It's not just, that you need to add air to the water. Otherwise, the Kratky method and passive methods also wouldn't work in hydroponics. It's more than that. It's the microbial aspect. It's the so-called water molds or algae that actually affect this. And knowing this, then okay, it's important to sterilize my containers after each growth. Sometimes I can use aeration, sometimes I don't need to use aeration. So I think this is important to know, that you are curious enough to investigate what is the root cause, pun intended, I guess. What is the root cause of the issues that I'm observing with my plant? And not just defer to a standard, it's because it's too much water. No, think deeper. Try to figure out the actual cause. We have the science now to figure these things out. The third concept I think that is really impactful is when I started shifting from looking at very fancy, very futuristic looking systems and trying to use less energy and less materials with my own growing. So on the left here, you can see one of the systems that really wowed me the first time I saw. I think this is called the Omega Garden. I'm not specifically bashing the system. I'm talking about more of the general concept. This is a system that combines both vertical growing with a very interesting setup where all of the plants are rotating around a central artificial light source, and you have the nutrient solution in the bottom that is bathing the roots as they pass. This system, of course, uses a lot of materials. You have a lot of plastic. You have the light. You cannot use this system with the natural light, for example. And of course, you need to add your hydroponic solution, although maybe it could work in other ways. As a contrast, you have more of the passive method, where you can literally just grow it out of soda cans. As you can see here, there are some painted soda cans. These are all hydroponics. So you're already reusing what would otherwise be waste, and you can use these without an artificial light source. You don't need an engine to move the plants to bathe them in the nutrient solution. They're already there with everything they need. This, of course, is much more scalable, I think, than the other one that has a lot more upfront costs, and there's also a lot of things that can go wrong. There's moving parts. The motor can fail. There's water that can get into certain connections, I guess. I'm more about the moving parts. The less moving parts, the best in general. Also thinking about like systems with tubings, you always risk a leak if you have a recirculating system, whereas if you have a passive system, you don't have that kind of trouble. So something to think about. Another one is, of course, cloning and propagation. A lot of people don't know this, and they always start their plants from seed, but you can actually clone plants. Basil and tomato, here are the two examples I put, but there's many more. You just have to search for them. It's enough to cut part of the plant and put it in a jar with water or a glass with water and wait for the roots to develop. And then you can put that into your hydroponic system or the soil, and you're ready to go. You save time by skipping the germination process. Of course, there are downsides. By cloning, you're sticking to one specific genetic material, so if there comes a pest or a bug that material is particularly susceptible to, you might have some problems. So it's always good, of course, to keep the reproduction going, cycle through different genetic material when you're doing your growing. But this is a very important tool, I think, that a lot of people should do more. It's so simple. It's simpler than seeding as well, because with seeding you have germination rates. You have to think about if the plant is a light seeder or a dark seeder, that I will talk later. This one is just simpler, and I think if you use this as a toolkit in your growing arsenal, I think you will have a lot of success. Number 5, that's something that I didn't really think about. I knew it in the back of my mind, but I guess it never really was a problem, so I never thought about it. But if you really want to maximize your success when you're growing, thinking about how different plants tolerate light better, and here I'm talking about light, but it could easily be humidity and other things like temperature. But for example, light is one of the things that we don't tend to think so much about. We just think, okay, the plants have leaves, we can put them in the light, and that's it. Whereas some plants prefer a little bit more shady areas. And you can actually construct balconies or even your own indoor growing system with artificial light in such a way that you take advantage of this. You have, of course, the plants that require the most light, and you can Google these things, getting that hit of the light directly. And then in areas that get indirect light, you can have different types of plants. And then in actual shaded areas, you can still grow some other types of plants. So knowing this gives you a lot of creativity and really maximizes, I guess, your productivity in terms of both the quality and the quantity of things you want to grow. This is a bit one of the things that I learned more recently, and I always assumed that all the seeds you add a little bit under the soil or the medium and you wait for it to germinate, and that's it. But some plants prefer light germination, that you literally put them on top of the surface and then they will pop, germinate, and then the roots will go down and then the leaves will go up. Some other plants, some other seeds prefer to be dark and how dark, it also depends on the plants. You can also Google, there's lists out there with that tell you for each common household crop, the crops we usually talk about, leafy greens, herbs, and some fruity vegetables and other types of vegetables. For each different type of seed, okay, I can do this in bare light, whether artificial or natural. I can do this as well in terms of how deep you put it in the substrate that you're trying to germinate it in. And of course, other conditions apply as well. Remember the temperature, the humidity, and all these things. But the light is actually quite important. So, for example, recently I was having a lot of trouble with my lettuce, so I looked up. Okay, I know the lettuce is a bit it's a bit of a dark germinator, but I wasn't really sure how dark it really wanted to be, and just putting it a little bit on my substrate wasn't working. And then I found this method online, and I just put it in a Tupperware with wet paper, and I really put it in the dark for 24 hours, and I had close to 100% germination rate. So really, take the time to Google for each plant you want to find what are the specific conditions, and I think you will have a lot of success. That investment you take in time and effort to learn actually pays off in a big way. Okay, so this is more related to hydroponics, because in hydroponics you can more easily change the pH that you're dealing with, whereas with soil it's a bit harder. You can do it with time, but it takes a bit more effort. A lot of people already know this, of course, that more or less there is a range of pH that plants prefer to grow in, between 5.5 and 6.5. Here you can see in the image here how actually that range is kind of an average for each different compound. So each different compound kind of has a greater availability for the plant, and in a certain range. And I put here just an example that there are tools that you can use to change the pH depending on what you need. I'm not really sponsored by this company. I just found this on Google, and it's one of the things I've used, but I've used other things as well. You have your acid and you have your base. Anyway, the point here is really to think about that. Okay, maybe in mineral hydroponics it's kind of simpler because you have a lot more control. Things are more sterile in general, but I find that at least in organic hydroponics, this comes up very often, especially if you're trying different things and you have a lot of compounds as the nutrient source that you don't know what you're doing with, really. And sometimes the key factor behind your success is really you need to account for the pH. So I've done experiments where I added my organic nutrient source and it wasn't really working. I was measuring the pH, but I wasn't doing anything about it. And once I actually added, for example, an acid to lower the pH to that target area, then things started working better, because suddenly all the other compounds that the plant was not able to get into itself and to use as building blocks, suddenly they were available. And you can actually go deeper into this and understand what actually is pH, the concentration of ions, and how the plant works with that. I recommend that you also take the time to delve deep into that topic. It's a fascinating topic, and you will understand things in a much more holistic way, in a sense, but also in a specific way, how what you're doing by adding these minerals or by changing the pH is actually affecting how the plant has more access to things to work with, basically. Piggybacking a bit into other concepts I talked about, like the pH and for example the light and other conditions. Not all compounds that you add to your system, for example a hydroponic system, are readily available for the plant. Here I have three examples. The first one is urea. Then you have here in the middle ammonia, which already, depending on the pH, can shift between ammonium and ammonia. And then lastly you have nitrate, which can also shift depending on the ions. This to say that all of these are a source of nitrogen, but not all of them are as available to the plant. So urea is basically not available, the nitrogen there is not available for the plant to use. The ammonia is slightly available, but still in very insignificant quantities for the plant. It's only when you reach the nitrate stage that you can actually enable the plant to fully take advantage of that nitrogen. And I'm talking about nitrogen here, but this applies to all the other compounds. Of course, in mineral hydroponics, you don't usually deal with more complex compounds. All the compounds are already in very plant available form. And sometimes specifically when you have the 3-part solutions or the 2-part solutions, they are especially available. And but when you're doing a bit more experimental organic hydroponics like I am, you have to think about these things. That's why sometimes we need to add biofilters, or just basically something with surface area where microorganisms can grow that convert compounds that are not readily available for the plant into compounds that are available for the plant. And of course, doing that has a cost. You need to sometimes recirculate the water, you need to add oxygen to the water. So those are all things that are important to know about. You really have to think about, especially with organic compounds, are these available for the plant? What does the plant prefer? And what can I do to allow the plant to reach that stage where it can use what it needs? One of the more complex concepts, and I guess far-reaching ones that I more recently learned, I actually learned this from a book called The Ecology of the Planted Aquarium. Very interesting book. But one of the concepts that talked about there, which I had never considered in regards to soil growing or hydroponics, is allelopathy. This is basically the concept that says that plants, as they go about their metabolism, they sense each other underground, or in the case of the book that I was reading, in an aquatic environment. But whether it's the soil or it's an aquatic environment, they sense each other and they send chemical signals that can foster the growth of their neighbors or hamper the growth of their neighbors. So once I learned this, it's kind of like, you're realizing there's an entire chemical warfare going on under the ground or under the water that you're not aware of. And this is why things like companion planting are a thing. Some plants don't like being next to the other plants because these plants are actually in war with each other, in a sense. They are releasing chemicals that are preventing the other from succeeding. And this goes back to the importance of goes back to the question why it's important to, after you have a growing season with the soil, to let the soil rest, or to add nutrients to the soil, or to sterilize the soil in some sense, in some cases, or more specifically in hydroponics, to sterilize the container and to empty that remaining nutrient reservoir, because that has chemicals that might affect the growth of the next plant you add there if you just added water, for example. So here in these images, you can kind of learn a bit more of the details about how things can be suppressed, or things can be inhibited, or things can be promoted. And it's fascinating. And it's still, I would say, very early, because we don't know exactly all the ways in which plants are communicating with each other to make this happen. But definitely an area that I'm keeping my eye on. And we usually refer to this more in terms of, change nutrient solution after you're done with your harvest, sterilize containers, for example, and let the soil rest, or don't plant the same family of plants in that soil right after, let it change to a different family that might be compatible with the previous one. So yeah, keep that into account, and also feel free to learn more. I think this is probably one of the key research areas in the future to maximize crop production. And lastly, I think the key pacing that I found more, the key concept that I found more impactful was pacing myself. I know once we start getting into this rabbit hole of growing and we start realizing all the things that we can do, okay, we actually have space in the house, or we have a balcony, or we're moving to a bigger place with a garden, we can grow all these things. Take it easy, pace yourself, learn the things, start small, and then grow. So here, for example, you can see my first home aquaponics system, which was already quite an undertaking for the quite a journey for someone that had no experience in hydroponics to start with aquaponics. In retrospect, I would have started first with hydroponics and then grow to organic hydroponics, which is aquaponics. But at first I started with that system, and that was already above my expertise or my skill level, so it took me a while to really master that. Whereas if I had started with hydroponics, maybe I would have been able to shorten the time I had of the things I was having trouble with. In any case, I recommend you start small. For example, here I was doing my thesis. This was part of my education, so I didn't really have a choice in the pacing, but still I had help from my coordinator. But for example, maybe you start with a small system at home and then you have a little greenhouse that you want to grow with. Start first with the one at home and really master that, and then think about the greenhouse. And of course, the last one, I was already operating a commercial system, which was the last video I uploaded. That, I would say, is really the last thing you should do. You should really be comfortable with growing large amounts of crops and getting into the routine of when to seed, when to harvest, and what things to look out for, pests and leaks, and the light is too far apart or too close apart, and what compounds do I need to monitor in my system, for example. What other things do I need to take into consideration when I'm starting the plant or when I'm harvesting the plant? What to do with the waste from eating the plant or just the waste from harvesting the plant? Getting all those things working first at a household level, I would say, would make you more prepared to really start a commercial system. And that's also important because a commercial system requires a big investment in capital, in equipment, in recurrent energy costs, for example, and other costs, and of course of time. You need a lot of time to operate a commercial equipment, and there's other skills unrelated to growing that you need to also know to operate a commercial system, with regards to maybe marketing or how to sell your produce, which channels can you approach in that sense. So all in all, I think these 10 concepts are the ones that I found the most impactful to me, the ones I really, when I think back, I can see it was a little bit of a milestone when I realized these things for myself. So I hope they were as interesting and as exciting to learn for you. And if you have questions about them or comments or other concepts, I would love to hear your concepts, concept that you think like it was a milestone when you understood it really, and that it changed the way you saw growing or how effective you were at growing. So feel free to share them in the comments, and I will try to reply to them if I can. And thank you for your time. See you on the next video.